Welcome to lesson 17 of this Arduino C++ course, and today we're going to get started with the 1602A I2C LCD screen. So let's have a look at the breadboard. Well, I say breadboard, there's a bit of a lack of breadboard today. So all we have is the screen here. As you can see, the display is running away. Now, these displays are actually used in commercial projects. This is my model railway controller, an NCE power cab, and as you can see, the display that is fitted in here is actually one of these screens. So these are used in real projects, not just for messing around with the Arduino. Now, screens form a very important part of Arduino programming because although we can display data to the serial monitor, it's not much use if you wanted to make maybe a password protected door lock or something like that. You need some kind of display so that people can see what's going on and get some kind of feedback. So that's what we're going to look at today. We're also going to look at, if we look at this as the number increases, you can see how the spaces have appeared here. We're going to look at some of the issues around string padding and some of the lessons we can learn that apply not only to this display, but to all LCD displays, even the fancy touchscreen ones. Now, if you want further information on today's lesson, just follow the link here to the Digital Town Lessons page. We go over to that page. Obviously, you will find this screen, work down to lesson 17. My goodness, it's a bit of a scroll down, and you can see the project to download the code and, of course, get the circuit diagram. Clicking on the circuit diagram, as always, brings up a larger version. Right, let's get down to the screen itself. Now, before we go any further, I just want to apologize for the sound quality. There's nothing wrong with the computer. Unfortunately, the fault is with me. I have one terrible cold, so apologies for my poor voice. Right, this is the screen that we're going to be using today. Now, one of the things that irritates me with starter kits is very often they will come with this version of the screen. Now, the front of the screens all look identical. In fact, the screens are identical. The difference is that when you use this version of the screen, you need, I think it's 6 connections to the Arduino, whereas the version we're going to be using today is the I2C version that only requires a ground, a VCC, an SDA, and an SCL. So basically, we're going to use up 2 of our pins rather than 6 of our pins, which on the Arduino Uno is quite a saving. If you're wondering what this item is here, you can put a screwdriver in the back of this and just adjust the brightness of the screen. Now, to make things a little bit more confusing, there are even 2 versions of this. These are an I2C backpack, they're called. So all those connections that would have gone to the Arduino go onto this little board that sits between the screen and the Arduino. The connections are identical between the 2. The main difference is the way the board is laid out. Obviously, this has got a much nicer adjuster than this little cheap thing here. And you'll notice these little solder pads A0, A1, and A2. They are also laid out in a slightly different direction. They work absolutely identically, and you can interchange them as you want, and I'll explain a little bit more about the back of the boards as we progress through the project. So here we are on AliExpress, and what are these boards costing? The normal version that you would get is £1.59 plus £1.38 postage. This is the first one I think I've clicked on. The I2C version with the backpack is £1.79. So 20 pence difference. It's a little bit irritating. Obviously they want to save money on their kits. There is the green screen version, or you can get the bluer version. Again, the difference is one has the I2C version, one is the just pins straight to the Arduino. but as you can see, they're cheap boards to get hold of. The I2C version, of course, has this advantage that you only need 2 of your pins, and as you'll see, those are analog pins. So coming back to this unit, what is I2C, or sometimes it is called I2C? Different names, same letters, who cares? It is a form of serial communication. Now, we use serial communication when we send data to the serial monitor. However, the difference with I2C or I2C is that not only does it have the 2 wires that normal serial communication would have, but each component has an address. So rather than sending this information out on the serial to anything that is on that serial line, it will be sent out with an address header so that only the item with the correct address picks the item up. So it's a bit like each item has a house number and it is on a road, and the system knows which unit, if you like, to post the data to and which unit it is receiving the data from. So let's get started with the Arduino and we will get this circuit built up. So looking at this circuit, as you can see, it's quite simple. You've got 5 volts that is going to the VCC, ground connected to ground, don't forget the ground. We then have pin A4 that is connected to the SDA pin, and we have A5 that is connected to the SCL pin. Now, these pins A4 and A5 are specific on the Arduino Uno, and the reason is, if we come to the reference document for what is going to be called the wire library, and we'll look at that a little bit more in a moment, we can see that for the Arduino Uno R3, it's pins A4 and A5. On the R4, it's A4 and A5, but some of these, as you can see, have other, you can sometimes have 2 I2C and even 3 I2C buses on the same board. If we look at the Mega, can I see that? Yeah, we've got the Mega here. You can see that it's pins 20 and 21. So it's quite important that you check the reference if you're using another board apart from the Uno, because the SDA and the SCL pins will be different on each board. However, for our purposes, it's pins A4 and A5. Now, to use I2C on the Arduino, we use the wire library. Now, the first thing we need to do is find out the address of our boards. And for that, if you go into your examples, go down to wire, and then go to I2C scanner, we can get started. Now, what this does is it basically writes to the serial monitor the address of any board that it finds linked to the wire system. Now, I've uploaded the sketch, and you can see that it is saying that is found an I2C device found at the address 0x27. So this is the hexadecimal value of 27. Now, if I bring the image back in of the board we're using at the moment is this board, this screen, and you can see that A0, A1 and A2 have no solder blobs across here. Now you'll notice that this other board here, I have soldered across one of the contacts, and what this allows you to do is to change this address. So I'm just going to quickly attach the other board and you will see the address change. Okay, the other board is now attached, and as you can see, I am getting an address of 25. Now this is because, as I've said, this solder tab is soldered across. If I'd soldered across A0, I would have got an address of 26. I actually built 3 of these boards with different addresses because I had a project with 4 screens all running together. You can daisy chain the SDA and the SCL pins, They don't need separate pins on the Arduino. They all connect to the same address, the same pins, because each board has its own unique address. So the data knows where it's being sent to and where it's coming from. So now we know what the address is, let's start to work with the screen itself. Now for this sketch, we are going to require two libraries. One is the wire library. Now when we click on the examples, you will see the wire library, and that gets downloaded automatically with the Arduino IDE. However, the liquid crystal I2C library is not included automatically, and so for that we need to click on libraries and then just put in liquid crystal and then a space. I'm going to put I2C. Let's see what we get. Liquid crystal I2C, and the version that you want is by Frank de Brabander. Thank you very much to Mr. Frank de Brabander. Can't pronounce your name, but thanks for all the work that you put in. By the way, these libraries, when people donate them, sometimes we don't appreciate just how much work people have put in, and they're not making any money off this. So to install it, literally click on the latest version, and obviously I've got it installed, so I can't do anything. You just click on the install button. It will install it straight into your IDE and you're ready to go. Now, again, trying to put the header file in can be a bit of a problem. So what we can do is if we go to Sketch, we can go to Include Library, and the two libraries we want are the wire library, that is the I2C communication, and the other library is the I2C liquid crystal. He says, looking down this massive list of libraries, there we are, liquid crystal I2C, and you can see that it will put that information in for you into the header of your sketch. Obviously I've put them down here. The reason I don't use the angle brackets is that very often when I'm putting it in HTML code on the website, these things really mess up the code. But if you want to make sure that you don't have any spelling mistakes, just use that sketch and include the library and it will be fine. Right, so sketch 1 LCD 1602 ITC version I2C version 1. Here we go. So once we have included the library, the first thing we need to do is create our screen object. Now, I don't want you to panic too much about that. What we're going to do is it is calling the library up, and we're going to call our screen LCD. Very, very boring. Remember that address 0x27. We're going to put the address in, and then you'll notice I'm going to put a 16 and a 2 because the screen that I am using is a 16 by 2 screen. Now there are some screens that are 20 characters wide, and there are also some that are 4 lines deep. So depending on the screen, you set the size of the screen. Now once that's done, if you come down to the setup, all we're doing is starting the serial monitor, printing out the sketch name to the serial monitor, and then we are going to start the wire library. So wire.begin starts the I2C bus, because obviously we've got to start that communication. It's very similar to going serial begin. Wire begin says, okay, we're going to start looking and we're going to start sending and receiving on the I2C bus. In a similar way, when we started the library for the LCD screen, we created an object called LCD. And we now communicate with LCD.init, which means the same in many ways as begin. It's initiate. Usually it's just a part of the library, and that's something that says to the library, let's get started. You also then should really call this function lcd.backlight, because if you don't call the backlight, the screen goes really dull. After all, there's no point having a display if you can't read it. And then for this sketch, all we're going to do is print out hello on the top line, and on the bottom line, we're going to write second line. Now, we have this bit here where it says lcd.setCursor, and this is saying where you want the first character to begin. So 0 is the starting character. I find this a little bit back to front, so it's character first, then the line. So we are on character 0, which is the furthest to the left, and then line 0, which is the top line, and then all we're going to do is print hello world. In many ways very similar to the way that you would send data to the serial monitor. Then we're going to reset the cursor, and we're going to set it to character 4 on line 1, and this time we're just going to print out the line second line. Now, if everything is connected correctly and the sketch has worked, you will see that line 0, character 0, is where we start the hello world. Then character 4, and you might just be able to see it, 0, 1, 2, 3, 4, line 0, 1 is where we're going to print the second line. Now, what I'm quickly going to do is I'm going to comment out the backlight line, and I'm going to upload the code again just so that you can see what happens without the backlight. Now, if I just tilt this just right, you can actually see that it still says hello world second line, but unfortunately without the backlight it's unreadable. So that is why you need to start the backlight. So I've put the backlight back on again, and again, just as a reminder, character 0, line 0, that is top left for the hello world. Character 4, line 1, that's where we did the second line, which leaves 4 spaces before this starts, because the line starts with 0, not with a 1. Now we know how to, if you like, position our text. Let's get on to something a little bit more interesting. Just one thing that I forgot before we leave this one sketch. You remember I called this LCD. Now I have an alternate screen. I could use multiple screens connected together. So obviously you can't call them all the same name. So if you used LCD as the name, then we have lcd.init, lcd.backlight, lcd set cursor, lcd print. However, if we change that name to my screen, just as an example, then all your functions would start with myscreen.init, myscreen.backlight, myscreen.setCursor. It works exactly the same, but whatever name you put in is what would be called. And of course, for my particular board, we would have to put a value in of 25 because that was the value my board had. So if you're using a different name or a different address, that is what you would do. Now, most of the time we're just using a single screen, and that's what we will be using in Sketch 2. Now, once again, I've put the connections in between the screen and the Arduino in the sketch. Include the libraries, create our object. We're going to stick with LCD, and again, address 27, 16 across by 2. Now, once again, we're going to be using some timing in here. So we're going to have current millis and update millis. Update millis is going to be the time at which the screen is updated, and we're going to update it every 0.25 or 250 milliseconds. And we're also going to create a variable called myByte. Now, it is just a byte that holds a value between 0 and 256. And the reason for doing that is that by using this value, when it gets to 255, 255 plus 1, if you are a byte, equals 0. It does not go to 256, it goes back to 0. Now the reason is, if I bring up my calculator and we switch it into programming mode, if we go to a value of 255 in decimal, 255 in binary, 111111111, 8 ones. So if we add 1, the byte is only 8 bits long, so it will not store the overflow. So it will go from a full set of ones back to zeros and start again. Now, the reason I wanted to do this is I'm going to show you a problem that happens not just with this screen, but with all screens. Now, before we put 2 set fixed bits of text in, this time we're going to put 3 bits in. We are going to put a title, DEC, which is going to stand for decimal, HEX, which is for hexadecimal, and BIN, which is for binary. Decimal is going to go top left, hex is going to go position 9 on the first line, line 0, and the binary is going to go on the bottom line, which is line 1, and it's going to start top left. Then what we're going to do is start a timer, and it's the usual timer that we've seen in the lessons before. It's just going to update every 0.25 of a second. And when it does, we're going to increase the value of my byte by 1. So my byte plus plus is the equivalent of my byte equals my byte plus 1. It's exactly the same, but obviously much faster to write. Now, when it does that, we are going to set the cursor to position 5 and 0. So this is going to put the value, we're going to go 0, which is going to be the D, 1 is E, 2 is C, 3 is the colon, and then 4 is going to be a space, 5 is going to be the value, the binary value. We're going to do a similar thing. We're going to set the cursor for a hexadecimal value, and we're going to do the same on line 1 for a binary value. So once again, we set the cursor and then we write to the screen. So let's get this thing uploaded. So the sketch is now uploaded, and as you can see, this value is increasing. But I want you to watch what happens. If you can imagine, the string is starting to print at character 5, but when we get to 100, you will see it jumps along a line, and we have a similar problem with the binary value here. There we go, it's jumped across, and in many ways for me, that is not attractive to the eye. But if we keep watching, we will find another problem. So to save your boredom, I've cut a little bit of time out. Now watch the value when it gets to 255, because at 255 it's going to go to 0, and this binary number will also go to 0. Now notice it didn't go to 0. We can still see the 5 from the 255 that's left in there. And this is a problem with all screens, that they do not automatically clear any data. In fact, they leave any data on the screen unless it is specifically overwritten or deleted. Now, just to emphasize this, what I've quickly done is I've uploaded the blink sketch. You can see the LED is flashing away over here, but you can now see that even though the Arduino is not even speaking to the screen anymore, the wire library isn't running, the screen will continue to display whatever was last sent to it. So we have to send information to the screen if we want to change what is seen. So for sketch 3, everything runs exactly the same. Setup is exactly the same. It's just when we come down to the main loop. Now before, we were setting the cursor at position 5 on line 0, that's the top line, and we were printing out the value of the byte. Now what we're going to do is at position 5, I'm going to actually print out 3 spaces. So what we're going to do is print out 3 spaces to remove any existing text. Then we're going to print the new text on top. For the binary value, I'm going to have to send out 2 spaces. And for the, that's the hexadecimal value, is 2 spaces. The binary version, I'm going to have to print out 8 spaces. So let's get that uploaded, and you can see the results. So that's now uploaded, and as it's running through for the first time, it shows no difference at all. What we now need to do is see what happens when it gets to that value 255 and our number goes back to 0. As you can see, because we're printing a set of blanks, it immediately removes all the old text and it starts again quite nicely. However, from my point of view, I still don't like the idea that the text starts at the left and sort of expands to the right. It seems a bit odd. Also, the camera doesn't pick it up, but there is actually a very sort of odd flicker that happens because obviously it's having to write to the screen twice. So actually your eye does see nothing before it sees the new value. So what we're going to do is look at how we can deal with everything in one single write maneuver. So here we are, sketch 4, and we're now going to start to use padding. Now padding, put simply, if we can imagine the way our numbers work, we've got 1, and then we've got 10, and we've got 100. Now if we want to pad those numbers, we have to put space 1, go back again, space 10, 100. Now at that point, the number now aligns on the last digit, whatever that digit may be. Now sometimes you want to pad with a space. Sometimes if it's a binary number, you would usually pad it with a 0 because it helps it to look correct. So depending on what you are doing would depend on the type of padding that you want. So going down through our sketch, it's exactly the same as before. Everything above the setup is the same. The setup itself is the same. Now we're going to look at some methods of string padding. Now the first value that we are printing out is a decimal value. So what we could say is, if the value is smaller than 10, then we need to put 2 spaces in. Else, if the number is smaller than 100, we need to put a single space in. That's a very, very simple way of creating a string. So what we're saying is we've got a new variable that we've created, myString. MyString is going to consist of either 2 spaces, 1 space, or no spaces, and then myString is going to equal myString plus the string of my byte. So that is the string value of my byte rather than the number. The numeric value may be 100, but the string value is character 1, character 0, character 0. Then what we're going to do is just set the cursor once and print that out. Now that's fairly easy for a byte, not a big problem at all. We've then got the hexadecimal value. Now the hex value is going to be below the hex value of 10 or greater than that value. If it's got a hex value below 10, then it's just going to add a single space. not difficult at all. And again, we're just going to set that cursor on character 14 and output our string, which again, this time it's going to be the string. Obviously, we reset my string after this little bit here, set it back to nothing, work out whether we need a space, and then obviously add the hexadecimal output of the string. Finally, we come down to the binary version. Now, the binary version is a pain because obviously it can be up to 8 characters long. Now, if I was going to start writing it a bit like this, and it could be done like this, obviously this if statement is going to be coming out, it's going to be getting very, very long. So what we're going to use is a value of string length. So my string is reset, and then we know that my string is the string of the binary value of my byte. Then we're going to use a function called string length, and this is going to find the length of the string. So if it's 10000, it's going to give a value of 4. I'm then going to serial print that out just so that it helps on the serial monitor so I can work out what I can do. And then we know that the maximum number of pads, which in this case we're going to be putting a 0 in, is going to be 8. But it's going to be 8 minus the string length. So if our string is 5 characters long, then the number of pads we're going to need is 8 minus 5, so we're going to need 3 pads. Now to put those pads in, we're going to use a for loop for q equals 0 to q is smaller than the number of pads, numpads, and we're going to go pad string equals pad string plus a character 0. Finally, my string is going to be the pad string at the front plus my string, which is the binary value of the number, and we're going to print all of that out in its relevant position. So it's uploaded, and as you can see, we are now starting to write the values correctly. We have a pad in here, which is a single space, and you can see that in the hexadecimal value, we've got a single, well, there's no pad at the moment because it's over the value. And we can see in the binary value that we have the zeros working as a pad. Also now, if we keep watching, especially the binary value, you'll see that it pads very nicely with the zeros when it starts again. And again, the decimal value, it shows up really well. So I think that's a reasonable success. However, there is a downside. With that code that I've just written, we've got one method that we're using up here. We've got a second method that we're using for the hexadecimal value, and we've got yet another version that we are using for the binary version. So what I'm going to do in the final sketch, I'm going to create a function that you will be able to use not just in this project, but in any project where you need string padding. So here we are, sketch 5 with our improved function. Again, everything down to the setup remains the same. Then we come down to our loop. Now what I've done is commented out the code from the last way of padding the strings to show you the improved way. And what we are going to do is we are going to send it to a function called string pad. Now this is a function that I've written down here. It's a simple function. I use this function in all sorts of screen utilities, even on some of my touch screens that I'm using. I use a very similar method to this. In fact, I think it usually is this function. So this function takes 3 values. It takes the number of pads. So if you like, how long is this string meant to be? How many characters long? It then takes a pad character. What character do I want to pad the string with, and finally I send the string that I want padded. As a return from this function, I get the finished padded string. Now what it does is it looks up the string length. In fact, it's very, very similar to what we did with the binary version. But if you like, this time I can actually change these variables as I want without rewriting the code. So we take the string length of the pad string. So we create a string, pad string. We then get the string length, which is the length of this string to pad that has been passed over. The number of pads equals numPads minus the string length, just as it did with the binary version. So it now runs around a for loop, creating, if you like, a pad string made up of the character that we pass. Now for the binary, it could be a 0. For something else, it could be a space. It could be a pound symbol. It could be a hash symbol. Whatever you want in there, you can choose what goes in. And then the string to pad is the pad string plus the string to pad, and it returns the value. Now that means that for each of these items, to do the binary, the decimal version, instead of these lines of code, all I needed is my string is the string of my byte, and now I send my value, my string, to the string pad function. I want a maximum of 3 characters. I'm sending a space as my pad. I've sent my string over, and my reply comes back and refills my string, which I then print out to the screen. I've then reset my string. This time we're doing the hex value. So again, it's taking the hexadecimal value as the string, passing it over. Again, I want a space. This time the maximum length is 2 characters. Once again, I can print it out. And now we're going to come down to the binary version. Now we're not going to need some of these variables anymore, so these can be commented out. We're not going to need those, so those can be commented out. So all we've got is my string. My string equals the string of my byte, but the binary value, and then we're going to pass that value to the string padding function, telling it that we want a maximum of 8 characters. 0 is our string padding value, and we want it all returned in the myString variable. Let's get that uploaded. So here we go, the new version is uploaded, and as you can see, it looks just like the version before, but of course this time we have far less lines of code because we are calling that single string padding function. And as I've said before, you can use it not just on this screen, but on various other screens, even up to the quite expensive sort of LCD touch screens. The same function works in exactly the same way on those screens. Now, just as before, using the same function, when it gets to the 255, when it goes back, all the padding is handled correctly. And from my point of view, looking at this screen sort of from an angle, the great news is that I'm not getting that flicker that I was getting when I was using that sort of printing a blank out before printing the true value. So I hope that one's been a useful tutorial for you, and the reason for doing this screen at this point is obviously on the beginner's course I will be using this screen over a number of projects, and for those of you who follow the model railway projects, I'm also going to be using the LCD screen for that. The reason that I've done the tutorial, as I've said before, on the I2C version is just to save on pins, because obviously when a project gets bigger, you want as many pins available for buttons, switches, sensors, etc. as possible. Anyway, hope that's been good for you. Sorry about the poor sound quality. I will try and get my voice fixed as soon as possible. And if you can help the channel, please click the like and subscribe button, because it does help on the dreaded algorithm, however YouTube works. Anyway, thanks for watching, and I'll see you in the next video. Bye for now.